Hi everyone, welcome back. Today we are diving into one of the most powerful functions in the Pandas library is the pivot table. If you have ever used pivot tables in Excel before, you are going to love how flexible, easy and powerful they are in Python. Let's get into it. So what exactly is a pivot table? A pivot table is a way to summarize, group and analyze the data, especially when you are dealing with large data set. So you can aggregate values such as sum, mean, count. You can group by multiple categories, reshape data into meaningful format, and the best part is that you can do it in just one line of the code in Pandas. So let's get started. Let's import the necessary Python packages and read the Superstore dataset. So Superstore dataset is a customer transaction table where you will find customer ID, customer name, order ID, order date, ship mode, many more different columns for your analysis. So I have already written a small piece of the code so that we can get to the main topic, which is pivot table. However, you can see here we have 9,994 records in Superstore dataset, order ID, order date, ship mode, and you can see here order date and ship date are date time columns, whereas customer name, customer ID segment, they are object data type, whereas sales and profit are numerical data type. Let me clean our columns, and this is how our data looks like. To use pivot table, we have to set the index, we have to provide the column name which we are interested in, and we have to provide the aggregate function. For example, if you want to have total sales for let's say region south and subcategory is bookcases, what is the total sales of the value? So you would have to provide the aggregate function. So that are the main parameters of pivot table which you are going to use. So let's create a pivoted data frame, a very simple one, df underscore basic, df dot pivot underscore table, index, let's say we want to see region as a vertical column, and columns are going to be, let's say, sub underscore category. Values, we want to analyze a profit, and we would like to have the total profit by region for that particular category. So we are going to use sum. Let's run the code. Let's see how our data looks like now. So you can see here for every region and subcategory combination, you have got the total profit for that particular region and subcategory. So pivot table make comparison between groups very easy. In this instance, the difference between central and east with let's say bookcases, you can see both of these, or in fact there is another territory, region west territory, they are bringing in negative profit. The only territory which is profitable is south territory. Similarly, you can make very easily, you can compare central and south, that they are bringing negative profit. In fact, west is also bringing negative profit, whereas only east is profitable. So you can notice that the labels for each of the index and columns of a pivot table come from the unique value of the grouping columns. They are also sorted in alphabetical order. The intersection of each label is where the aggregated data appears. The pivot table method is very similar to group by aggregation. Both are capable of producing the same sort of the analysis, but in a different shape. Let's do an example of group by and see the output, and then we can make the comparison with the pivot table which we have created earlier. So df underscore group, df dot group by. By the way, we have discussed group by in pretty much in detail in the previous session. So if you guys are not aware of what group by is, or if you want to see the functionalities of group by method in Pandas, you can watch the previous session. Let's continue. and we would like to group by region and sub underscore category dot ag, and we would like to name it as sum underscore sales. Let me call profit, which we have done earlier, sum underscore profit, and we will call profit column here, and we will do the sum. Let's run the code. df underscore group. So you can see here the first 20 records. This call to the group by produces the exact same result as the pivot table, but in a different shape, having all of our data in a vertical columns, and it makes our life difficult when you want to make comparisons, and that is where pivot table shines. Pivot table produce wide data with new columns for each unique value of one of the grouping columns. Wide data is typically easier to read and make decisions with. The group by method returns long data with the results of each group in a single column, making it somewhat more difficult to make comparison. And this type of the data is generally easier to continue analyzing with further commands. And that is where I believe pivot table really shines when you want to make comparison, and on the basis of those insights, you would like to make decisions. For example, here you can see all the territories for machines are having negative profit, only east is profitable. By default, the aggfunc parameter is set to mean in pivot table. Let me show you what do I mean by that. Let me copy and paste this piece of code, and let me create a new table called df underscore default equal to, and let me remove aggfunc equal to sum, and let's run the code. And you can see here you have created a pivot table with mean profit for every region and subcategory. And even though I have not mentioned the aggfunc parameter equal to mean, however, if you are using the mean as your aggregation function, I advise that you explicitly state in your call to pivot underscore table so that it's clear what you are doing. Now let's say we would like to calculate the median profit for each region and subcategory, or if you are interested in calculating the max sales, max profit for each region and subcategory, you can easily do that in pivot table. For example, I'm interested in median, or let me copy paste this code. And what will I do is I will change the aggfunc parameter from mean to median. Let's run the code. Let's see the output. And here you can see I have generated the median profit for each region and subcategory pivot table. So basically, whatever the functions which are available for group by, or even if you want to use NumPy based functions, or if you want to create a custom function, you can all pass those functions in aggfunc parameter in pivot table. You can style any Pandas data frame by changing the text color, background color, font, and several other items with the style assessor. Just to save some time, I have already created a pivot table called df underscore reg underscore cat, where I'm computing the mean profit by region and category, and this is how our pivot table looks like. Now we will use the style assessor. The style assessor highlight underscore max method highlights the maximum value in each column or row. By default, it will highlight the maximum value of each column, just like most of the Pandas method. Let's see how we can use highlight underscore max method to highlight the maximum value in each column. df underscore reg underscore cat. Now you have to call the style attribute and then highlight underscore max. And you can highlight the maximum value for each column. It's that simple. Now let's say if you want to highlight the max value for each row, you have to change the axis parameter from columns to row. df underscore reg underscore cat dot style dot highlight underscore max access is equal to 1. And you can see here for each row technology is giving the maximum mean profit. One can also apply the background gradient color, the background based on the value of the cell. You can change the color by choosing the matplotlib color map. df reg underscore cat dot style dot background underscore gradient. Let me use cmap, sorry, spelling mistake, cmap equal to grays. Let's run the code. And you can see here, you can easily create a background gradient for our pivot table reg underscore category. If you would like to use magma or any other thing, just you change the parameter value for cmap, and this is how our pivot table looks like. One can use the pivot table method to get the total number of records of each of the grouping columns. When doing so, it is not necessary to use an aggregate column in the values parameter. Pandas knows that the size of the group is independent of what is aggregating, so it does not require you to provide it. Let's see an example how we can calculate the total number of the records in each combination. df underscore size df dot pivot underscore table index. By the way, it is a very common interview question, and I had seen a lot of people get, even the experienced data analysts or data scientists, they get stuck to this question. Sometimes the things you do on daily basis, even then people get confused. Category, and now I'm not providing any values parameter, for example profit or sales or something of that sort. aggfunc equal to size. Let's run the code. Let's see the output. And you can see here, these are the total number of the records for each combination of region and category in this particular pivot table. The optional parameter margins can be set to true to add one additional row and columns to the pivot table, which calculate the same aggregation function to the entire row or column. You can actually get the grand total for each row and column in your pivot table. So what you need to do there, so for example, if I would like to calculate the overall mean for, let's say, for entire row or for entire column, what I need to do is I would have to call margins parameter and I have to set it to true. By default it is set to false. Now let's see how our pivot tables look like. So you can see here there is an additional column which is all here, and it is giving you the overall mean value for furniture, supplies or technology, and here you can get it for central region what is your average sales value. What do we mean by that is, and this particular value 229.86 is an overall the mean sales value here. So if you would like to verify, I would call df sales dot mean, and you can see here the average sales value for our Superstore data set is $229.86, which is this one. One can use any number of the grouping columns when creating pivot tables. You just need to use a list to contain the columns you want for the rows or columns, and the resulting data frame has multi-level index. Let's do an example and see that. df underscore more underscore pivot df dot pivot underscore table index equal to region segment columns equal to category, values equal to sales, and aggfunc equal to, let's say, max, down to 2, and let's run the code. df underscore more underscore pivot. And this is how one can pass multiple columns in the index parameter and get the desired pivot table. One can also pivot this at multi-column level so that there is a multi-column level index. Let's do an example for that also. df underscore multi underscore column, df dot, let me copy and paste this thing here. And let's say for every region, and here I'm passing for every segment and category. Okay, let's run the code. df underscore multi underscore column, let's run the code. So for every region, first the data has been bifurcated by consumer, and then it has been, you are getting the output for each categories. So for consumer it is furniture, office supplies and technology. For corporate, furniture, office supplies and technology, home office. I think the better example would have been category and subcategory. Let me category and subcategory. So you can see here for furniture, bookcases, chairs, furnishing, tables and appliances are there. For office supplies, art, binders, envelope, fastener, labels, paper, storage, supplies and accessories. And for technology, it is copiers, machines and phones. And for every region, you can get their maximum sales value. It is possible to aggregate more than one column as well. All components of a pivot table are capable of taking multiple values, including the aggregate functions. Here we will find the min, max and average sales for each region and segment. Let me copy paste this code. df underscore ag, region, this is segment, value is sales, and here you need to pass a list of your aggregate functions, min, and let's say you also want to have mean. Let's run the code. df underscore ag, and you can see here you have got your desired pivot table where you can compare for each combination of region and segment what is their max values, what are their min values, as well as their mean values. So today we have learned how to create basic pivot tables, group by multiple dimensions and apply multiple aggregations. So pivot tables are game changer when you are cleaning or analyzing large data set, especially if you are reporting or would like to have comparative analysis. It is going to be very handy for any data scientist or analyst. So that's it for today, guys. Thanks for watching and have a great day.